factor by grouping. So when you factor by grouping, here's our equation here. You can actually rewrite the equation many different ways. So they've given it to us this way, so we have them in order of their exponent, right? This is exponent 3, 2, 1. You could say that's technically x is 0 because that's the equivalent of 1 and 1 times anything. But you can mix and match. For instance, we could, we can mix this around and have x cubed minus 9 plus x squared minus 9x. What you're trying to do is set up groups that are advantageous. Now, this is a relatively simple question. So they've already grouped our groups very nicely. We were going to group them into binomials. So put these two together, and I'm going to put these two together. There are times when moving this around, like to this, make better binomials for factoring. Okay? But in this case, they've done it this way. So I look at the first set of binomials, or the first group. What comes out of both of these? Well, I can take x, and not only can I take x, I can take x squared out. So we're going to divide both of these by x squared. So now that becomes like a common factor. We've taken x squared out, and what are we left with? Well,
x cubed.
Yeah, so x cubed divide x squared is x, and x squared divide x squared is 1. So there's what's left.
Okay, yeah.
And the other one, what can I take out of this? Well, I can take 9 out. I can't take any x's because this one doesn't have
You
it.
can take a negative 9.
Yes, exactly. Negative 9 will be even better than 9.
Yep.
So that becomes our common factor. And what are we left with? Well, that becomes x, and negative divide negative is positive. Perfect. So we've now created two brackets that are identical to each other.
Okay.
What's technically happening here is we are doing the exact same thing. We're taking a common factor out. So you could say that I'm factoring x plus 1 and x plus 1. But most people don't look at it this way. The easiest way to really do this is to just, because they're duplicated, write them out beside each other. We get x plus 1. And then the other bracket is just whatever's left over. X squared minus 9. And that's your factored form. We're done, but you're right. We can continuously factor. Now this is technically the factor by grouping part. This is now considered a difference of squares. It's no longer technically factoring by grouping, but
like you should continue to fully factor.
Yes. I'm going to tell you to continue to fully factor. There you go. You can get the page to go down. So we're just going to factor that one. So the very first bracket stays the same, x plus 1. Difference of squares work out really nicely. We're just looking for the square root of the first term, so square root x squared. That value is x. And square root of the other term. We're going to actually ignore that negative, so square root of 9.
Because difference of squares, it's just positive and negative, and that's all.
That's it. So we're going to use the plus and minus of 3. So that x will go into the first of each, and then we have a negative 3 and a positive 3. And now this is set with binomials that are all to the power of, or our variable is to the power of 1. So that would be the factored form. The very first thing we did was actually the factoring by grouping.